everyone, this is Aditya and today we'll discuss about reverse tracing in mathematics. But before that, please do like, share, subscribe my channel and please support video. Now let's start. Well, reverse tracing can have multiple meanings, but for today's video I'll be sticking to one definition only, which I'll be telling in a few moments. Well, that is all okay, but why am I discussing about reverse tracing? Well, I have few reasons for it. Let me tell you all. Well, reverse tracing is basically going from answer to a question. So basically, for example, if you know the answer but you don't know the question, so to form that question, reverse tracing can be very much helpful. But why are we even concerned about this? Because it is very much helpful in our daily life. Well, how? Let me tell you. Well, if I increase my domain from mathematics to other branches of science, then it is very much helpful in forensic labs, it is very much helpful in investigations, and it is very much helpful in our daily life. For example, let me give you an example too. Well, suppose you lost your phone and you can't remember that where you had kept, then how you find it? Well, you think of different places where you went and then you backtrace them and then eventually you go to the place where you had actually kept that phone. And that is how you find your phone, and that is what exactly known as retracing. So these are the few places where you can apply retracing apart from mathematics. But now let's move to mathematics. Well, retracing in mathematics is very much helpful for mathematicians and for paper setters also. Let me explain it. For mathematicians, they find some result and then they backtrace that and then they think that in what other cases we can apply the same result. So that is also an application of reverse tracing in mathematics. But I said one more interesting thing in case of paper setting, that how it can help. Well, just a minute. Personally, if you give me 10 minutes to make a question paper of 10 questions, then it is practically impossible to create those questions. Of course, you can copy from other books and then you can make a question paper. That is a different thing. But I am talking about creating a question. Then it is practically impossible. But if I say that it is still possible using reverse tracing, just a minute. Let me give you a simple example to understand this. Just a minute. Now just assume number 1. Okay, why am I assuming number 1? Just a minute. So 1 can be written as 2 times the integral 0 to 1 of x dx, correct? Now what is the integral of x? Well, it is equal to x square by 2. Now when you substitute the limits from 0 to 1, you will get 1 by 2. When multiplied by 2, you will get 1. So we haven't done anything wrong. It is just 1 is equal to 1. I have written 1 in a different form. Okay. So now 2 times the integral 0 to 1 x dx. Now is it wrong if I say 1 is equal to 2 times the integral 0 to 1 x dx multiplied by 2 times the integral 0 to 1 of y dy? Well, 2 times the integral 0 to 1 of x dx is also 1, and integral of 2 times integral from 0 to 1 y dy is also equal to 1. So it is just 1 times 1. Okay. Now is it wrong if I say x as x1 and y as x2? No, it's correct. So it is equal to 4 times the quantity integral 0 to 1 x1 dx1 whole multiplied by integral 0 to 1 x2 dx2, correct? I just multiplied 2 and 2 together to get 4, right? Okay. Now using the property of multiple integrals, I can say that it is equal to 4 times the double integral, and of course the limits are from 0 to 1 in both integrals, x1 x2 dx1 dx2, and of course it is same because we know the property of multiple integrals, right? Okay. Now is it any harm if I directly move to this step and I say that it is equal to 2 raised to the power n multiplied by the quantity, the integral, the n times integral of the quantity x1 x2 till xn dx1 dx2 so on till dxn. So of course this whole expression will evaluate to be 1 by 2 multiplied 1 by 2 and so on till n times. So it is basically equal to 2 raised to the power n multiplied by 1 upon 2 raised to the power n, which is equal to 1 again. So it is just 1 is equal to 1, right? So now we are moving a bit in a bachelor's mathematics. So let's see. Okay, so now what we can do next? Well, so we have already framed a question that prove that 2 raised to the power n multiplied by the n integrals from limits 0 to 1 of the quantity x1, x2 and so on till xn, dx1, dx2 and so on till dxn is equal to 1. So we have framed one question, but we can make it more difficult for a student to understand. How? Well, you can say 2 raised to the power n as equal to 1 plus the summation from I is equal to 0 to n minus 1 of the quantity 2 raised to the power I, and of course if you evaluate this, it will be equal to 2 raised to the power n only, right? So you can replace 2 raised to power n with this summation term, right? So it is equal to 1 plus summation from I is equal to 0 to n minus 1 of the quantity 2 raised to the power I whole multiplied with the n integrals of the quantity. The product from I is equal to 1 to n of xi dxi, and of course the limits are from 0 to 1. So we have framed another question that prove that 1 plus summation from I is equal to 0 to n minus 1 of the quantity 2 raised to the power I whole multiplied by n integrals of the limit 0 to 1. The product of all the terms from I is equal to 1 to n of xi dxi is equal to 1. So this is the final question which we can create. So of course what I have done is that I have just used a number 1 and then I backtrace to a question, right? So if I present it in front of a student, then what will happen? Well, it will be like prove that this expression is equal to 1. So of course they will first of all evaluate this expression and then they will say yeah, this is equal to 1. But what is out of box over here is that what they can use is that they can use 1 and then they can form that expression itself, and that is called retracing or reverse tracing. So I think you learned something new today, and yeah, I can give many other examples also if you want, but of course I don't think that it is very much practical to discuss all the examples. You can try yourself, right, in different questions. And I would like to say one more thing, that reverse tracing is very much helpful in understanding different concepts of mathematics. How? I've just explained it. So generally what people do is that they read a question, they understand this, they try to solve it, and then they come to an answer. But what they don't do is that they don't reverse trace that question. And reverse tracing is very much helpful for understanding any concept. And the most interesting thing over is that when I said prove that 2 raised to the power n multiplied with the n integrals from the limit 0 to 1 of the quantity x1 x2 till xn dxn is equal to 1, it is not just a question. Just notice this. It is telling another way to represent number 1, right? And that is really amazing. We can represent number 1 in different forms. We can also represent 1 as sin square theta plus cos square theta. So in fact this expression which I had said 2 raised to the power n times that integral is indeed equal to sin square theta plus cos square theta, and you can again manipulate this. You can also manipulate it like sin theta is equal to a raised to the power I theta minus e raised to the negative I theta divided by 2i, and cos theta is equal to e to the power I theta plus e to the power minus I theta divided by 2. And in fact you can write the Maclaurin form of sin theta also and cos theta, right? So it's like very much interesting. We can just manipulate things and we can get to some answer. So it is also really interesting how we can manipulate questions. The same question you can manipulate many times, right? So in a nutshell, if I say reverse tracing is very much helpful in our daily life also, in mathematics also, and in paper setting also, in for examinations. So if you did enjoy this video, then please do like, share, subscribe my channel, and please support studio. Bye bye, take care and all the best.